Good morning, everybody. Hope all is well. Today we're going to start chapter 2. Chapter 2 is about derivatives. Before starting the talk about derivatives, we need to define derivatives. And before we define derivatives, I need to tell you a little bit of a story on how things happened and and how the idea of a derivative popped up. And what is a derivative basically. Many students, if you ask them what a derivative is, they tell you, well, if you have x squared, it becomes 2x. So what is a derivative? Oh, you bring the power down, subtract 1. This is like the most common answer when students are asked what a derivative is. To be honest, this is not what a derivative is. This is how to get a derivative. This is a rule of finding a derivative, but it doesn't define what a derivative is. Let me tell you what started the argument of derivative and how mathematicians started thinking about it. Let's suppose we have the basic function y equal x squared. The basic function, nothing much. They said, you know what? If you take the point 1, 1, this point here, how can I describe this point in a unique way? They said, you know what? I should be able to express uniquely, in like a unique way, without doubt, about each of these points. So if this is 1, 1, I should find a specific characteristic. Just like in people, like you look at one person, you say this person, for example, is nice, this person is kind, this person is generous. So he has a unique characteristic just for him or her. So the same here, mathematicians started thinking how to describe a point, basically, with a unique character. What will we do? So first, they thought, you know what? How about we look at the slope of the secant passing through this point. So they drew secants like this. Is it easy to get the equation of a secant? Yes, if this is, for example, the point with x equals 2, we know y is equal to 2 squared, so 4, because we are on the curve. So for every x value, to find the y value, you just need to substitute. So there are 2 points. I know what they are. Can I find the slope of the secant joining them? A secant is a line that joins 2 points. Of course, the slope of any line is yb minus ya, or y2 minus y1 over x2 minus x1, which gives me in this case 4 minus 1 over 2 minus 1, which is 3 over 1. The answer is 3. But this was not satisfactory. Why? Because they said, you know what? This slope of the secant is not a unique number. Because if I take another point on the line, like the point, for example, half 0.25, this is a point on the curve, and I join them, I get another secant. So this becomes secant number 1. I now have secant number 2. And secant number 2 will have a different slope, because again, I'll do y2, which is 1, minus y1, which is 0.25, over 1 minus x2 minus x1. So this gives me 0.75 over 0.5, which is how much? 15. So again, are these slopes the same? No, they're not. So is it a unique characteristic? What if someone else around the world chose a different secant? He can do, how many secants like this can we find passing through the point 1, 1? We can find millions. Choose any other point. This will be secant number 3. Let's assume this, sorry, this is minus 0.5. I'm sorry. So plus, so 1.5. So it becomes half, sorry. Not a problem. All right. So here, for example, let's assume this is minus 1. What will the point be? Minus 1.5 almost. 2.25. So again, this will cause for me a secant number 3. Will we get the same slope? No, the slope of secant number 3 will be 1 minus 2.25 ala 1 minus 1.5, which is plus 1.5, which is equal to minus 1.25 over 2.5. It's now equal to minus half. Do you see how the slopes, they varied in a different fashion. This is only 3 secants. How many such secants can we create? We can create infinitely many such secants. So is it a unique characteristic of the point 1, 1? No. Every one of you can choose a different point and calculate a different slope. So they failed. Because you know, when you want to find a characteristic, you start saying, do they have this? Then you say yes or no. If no, you move to finding something else. So it didn't work. What they found was unique. I will draw the graph. Of course, with more and more research, they looked now at the point 1, 1. And they found something very unique about the point 1, 1. It's this special line. It's not a secant line anymore. It's called a tangent line. See, tangent lines are unique most of the time. When they exist, they are unique when they exist. You can only find one tangent line to the curve at a point if it exists. You can, of course, sometimes you fail to find it, but if you find it, it will be a unique tangent line. Tangent lines are lines that cut the curve only at this point. Doesn't cut the curve at any other place. It cut it بشكل إنه the point is on the curve and it's like the line is approaching it and it touches it at that point and continues. This we call it tangent line. Some students who have studied in Arabic, they call it خط المماس because it touches تلمس from one place and that's it. So هيدا tangent, they found it's a unique line. So they came and said, you know what? For every point, like 1, 1, the slope of the tangent can be a unique characteristic. They found a unique characteristic. What is it? The slope of the tangent. But, of course, the slope of the tangent seems to be a great thing about this point. But the problem is, let's calculate the slope of the tangent. How many points do we need to calculate any slope? 2. How many points do I know on the line? 1. So how will I calculate the slope of the tangent? See what happened? Do you see the story behind all of this? So they wanted for every single point on a curve to have a unique characteristic to describe it. And so they looked at that point and they said, you know what? There are millions of secants passing through this point. So those secants, we can calculate their slopes. How to calculate their slopes? It's very easy. y2 minus y1 over x2 minus x1. What are secants? Secants are lines that cut the curve in 2 points. So we know this point and we know this point. We do y2 minus y1 and x2 minus x1 over x2 minus x1 and we're done. But now it's not unique because how many such secants can I create? I created only 3, but you can create infinitely many. So it failed to be the unique characteristic they are looking for. But they started analyzing and they found that the tangent has the characteristic that they've been searching for. So it's the slope of the tangent line is something unique because if the tangent exists, then we can only find one and only one tangent, so its slope is unique. But the problem was, if the slope is the characteristic we're looking for, the slope of the tangent, then how can we calculate it? So obviously, this slope will represent the point. It's something very unique about that point. But the problem is, for every slope, we needed how many points to calculate it? 2. We couldn't get it. So the secant, its slope was easily calculated, but it wasn't unique. The tangent has a unique slope, but the slope cannot be calculated. But now, of course, again, they started solving and researching. And they started, as you will always see in our math course, we always build what we want to get from things we know. Since the tangent was hard, the slope of the tangent was hard to calculate, they said, let's try to make use of the ease of the secant to discover the secret of the tangent. So they said, let's build on what we know so that we can find what we do not know. How did they do that? I will show you an applet, a small applet on the computer, which shows you what happens to the tangent line and the secant line, how different they are. So let me show you. I will use x squared plus 1 because that's what we have in the applet. And the point they are studying is the point let me show you. So look at this graph. A is the point that we are considering, because here we have the graph x squared plus 1, then it's shifted 1 unit up. So instead of 1, 1, it will look like 1, 2. It's the same concept. So this is A, your point that you're trying to find a characteristic value for. And this is a point B on the curve. AB form a secant. This is the blue line. The tangent line is the green line. It's unique, it's fixed, so you cannot change it. This is the tangent line, and we cannot change it. Look what happens to B. I can move B, and this is how I get how many secants? Millions of secants. Do you notice? Are those secants the same as the tangent? No, the blue line is different than the green line. But notice what happens. If the point on the secant is chosen so that it becomes closer and closer and closer and closer to A, almost on A. So see, if it's far away, the secant and the tangent line are two completely different lines. But if I choose B such that B approaches A, and we have studied for 1 week the word approaches. So we know in mathematics now, we have a tool that studies approachness or closeness. What tool is that? The tool of the limit. See, look what happens. The secant and the tangent are not the same. But if B, which is the point on the secant chosen, is chosen such that B approaches A, the more B approaches A, what happens to the green line and the blue line? The blue line being the secant line and the green line being the tangent line. See what happens as B approaches A. As B approaches A, the secant line and the tangent line, they overlap. Do you notice? See, when B was far away, the blue line and the green line were not the same. But when B approaches A, the more B approaches A, more and more and more and more till it's the same, what happens to the tangent and the secant line? They overlap. Let me write in English so that we can translate together, because now we're good in some words, we can translate them. So let me write things in English to see if it works. Let's see. So what did we find? We want to find the slope of the tangent. We don't have a tool. The slope of the secant is very easy. Why? Because the slope of the secant will have the point A, which we are considering, and the point B, any point B you choose. What is special about the point B? The point B has to be on the curve. What does it mean for a point B to be on the curve? Yani if it has an x coordinate and a y coordinate, what should y be? Y should be f of x. It cannot be any point, any random point. It has to be on the curve. For a point to be on the curve, if y equals x squared, for example, what shall B look like? B has to look like x and x squared. This is how it should look like. So this is very important on how things are for B. 1 second only. So this is how things are for B. 1 second. All right. So this is how things are. So now what do we have to do? Now we have covered the whole idea. So what do we have to do? So what do we have to do now? We have to find the slope of the secant. It's easy. How do you find the slopes of the secant? If this is A and this is B, then y2 minus y1 over x minus x1. You're done. So slope of the secant is easy to calculate. Now choose the whatever B you want on the curve. Then the slope of the secant joining A to B is done. It's not a big problem, it's done. But the slope of the tangent doesn't have the same scenario. But we noticed from the applet that I just saw you that as B, the one that we are choosing, approaches A, as point B approaches A, what's happening to the slope of the secant? The slope of the secant approaches the slope of the tangent. How do we know that the two slopes approach? Because the secant line and the tangent line overlap. They overlap. Great. Let's analyze this mathematically now. What does it mean for B to approach A? When would B approach A? B would approach B as a point on the curve. So A is a fixed point. B is a point on the curve. It can be anywhere you imagine, right? But for it to be approaching A, so if this is A and I'm choosing B, for B to approach A, what should happen? The XB should approach 1. So the X value should approach 1. What happens when X approaches 1? It means I can call XB 1 plus a very small number or minus a very small number. So this H can be positive or negative, but it's a positive or negative small number. So if this is 1 minus a small number, we will be here. This is 1 minus a small number, we will be here, plus a small number, we will be here. Well, the smaller H becomes, the closer B is to A. When H becomes smaller, what happens to B? It becomes closer and closer and closer to A. All right? So this is now how we will choose B. Now, is B a point? Yes. Is B a point different than A? Yes, because it doesn't have the same X value as A. A has the X value 1. B has the X value 1 plus H, where H is not 0. H is a small number, but it is not 0. Now, can I calculate the slope of the secant joining A to B? Yes, easily. What is A? A is the point 1, 1. What is B? B, we chose it such that it's close to A, so it has X value 1 plus H. And what is Y value? What do students directly say? Well, the Y value is 1 plus H as well. It shouldn't be. No, we don't say this add to it H, then this add to it H. No, always remember what happens here. The Y value of B is the function evaluated at X. So if X is 1 plus H, the Y value will be f of 1 plus H. What is the function f? The function f is a square function. So it takes 1 plus H and squares it. So now what will the slope of the secant be? It will be y2 minus y1 over x2 minus x1. Of course, the denominator will not be anything but H, because x2 is 1 plus H, so x1 is 1. So when we subtract them, the answer will be H. What about the numerator? It's 1 plus H squared minus 1. This is the slope of the secant. I don't want the slope of the secant. I want the slope of the tangent. How is the slope of the tangent related to the slope of the secant? The slope of this tangent approaches the slope of the secant. What does it mean, approaches? I need to use the limit. So the slope of the tangent is the limit of secant A. It approaches the slope of the secant, approach the slope of the tangent only when B approaches A. When will B approach A? B will approach A when the difference between them, which is what? What's the difference between A and B? H. What happens to it? It goes to 0. So the slope of the tangent will be equal to the limit of 1 plus h squared minus 1 over h as h approaches 0. Always remember how we got things so that even if you forget the formula later on, you will know where it came from. See, I had a point 1, 1. I create a point close to that. What do I give it an x value? To say that it's close to 1, I will give it the x value 1 plus h. Now, what is the y value? The y value is always f evaluated at x. So it's f at 1 plus h. These form two different points, which form for me the slope of the secant. Joining them. The slope of the secant joining them is y2 minus y1 ala x2 minus x1. What is the slope of the tangent? The slope of the tangent is never equal to the slope of the secant. But the slope of the tangent is equal to the slope of the secant as A approaches B or as B approaches A. When will B approach A? When the difference between them approaches 0. So the slope of the tangent will be equal to the slope of the secant as h approaches 0, which is the limit as h approaches 0 of f1 plus h minus 1 over 1 plus h minus 1, which is translated into this. So this is a repetition, but in order for a layout. Now what do I do with this limit? This is old story. I do substitution. See, when I substitute 0, I'll get 1 squared 1 minus 1, 0 over 0. This will always happen to us because the denominator will always be h. So the denominator is 0. And upstairs, when I substitute h to be 0, I'll always have this number will be equivalent to this number and the answer will be 0. So what do I have to do? I have to do more work. What is the more work we do in such exercises? We expand and simplify. What are we searching for? We are searching to cancel h minus 0, which is h. So I expand, I get 1 plus 2 times 1 times h plus h squared minus 1 over h. The numbers will always cancel each other. What we will have left all the time are values that include h. So I take h as a common factor. I cancel the h with the h because now h approaches 0, but it's not exactly equal to 0. Then what do I have left? 2 plus h. What is the value of the limit of 2 plus h as h approaches 0? I substitute, I get an answer of 2. So what's the slope of the tangent at 1, 1? At the point 1, 1, the slope of the tangent is equal to how much? It is equal to 2. The first time you see this, it's complicated, of course, because it's not an easy thing to think of. But when you see it over and over again, you notice that it's mechanical. You don't have a lot of things to worry about. You just need to do it one step at a time. So let me show you an example. The more examples you solve, the easier it becomes. So for example, find to the function at x equals 1. Alright, this is what we want to find. The slope of the tangent line. What is the point we are studying? The point we are studying is x equals 1. So what does the point look like? X is equal to 1, y is equal to f at 1. this function, evaluate that one. This is the function we are studying. All right? So if you want to start, you can always start by saying 1 and f of 1. What's the point B we will choose? Because we don't want to find the secant line, we want to find the tangent line. But the tangent line uses the secant line so that it reaches the goal. So how do we use it though? We don't use it randomly. We use it such that the point we are choosing is very close to A. How do we mean very close? It means that it's 1 plus h. The common mistake here is that students write f of 1 plus h. This is not the case. They write the value here, the answer. So what's the answer here? F of 1 is 1 squared, 1 plus 1, 2. What is common mistake that students do? Let me write it in red, because all common mistakes, I'm writing them in red. What do students do as a common mistake? They write here 2, this 2 plus h. Mistake, big mistake, huge. This is not correct. What's the right way? You choose x. Y cannot be chosen. Y has to be f of x. So now what does the slope of the secant joining A to B become? y2 minus y1 over x2 minus x1. This is f of 1 plus h. Where will we find it from? We will find it from the function. So I don't have to worry about it. It's just a substitution. So 1 plus h squared plus 1, because you take 1 plus h squared plus 1, minus 2 over 1 minus 1 cancels. What do we have left? H. Now what do we want? We want the slope of the secant. What is the slope of the secant in relation to the slope of the tangent? The slope of the tangent is what happens to the slope of the secant when the difference between the 2 points becomes 0 almost. So when will A approach B a lot so that the 2 lines overlap? B approaches A so that the 2 lines overlap only when the difference between their x values approaches 0. So what's the difference between their x values? H. So when h approaches 0, the secant and the tangent will overlap, which means the slope of the secant will approach the slope of the tangent. So it's finding this limit, 1 plus h squared plus 1 minus 2, which is minus 1 over h. How do we find limits? We first try substitution. 1 plus h, 1 plus 0 squared, 1 squared minus 1, 0 over 0. We need more work. We are used to such examples. How do we do more work in such examples? We expand, cancel this and this term, and then I'm looking for an h, so I need to take h common factor. Left with 2 plus h over h. This and this cancels. I'm left with 2 plus h. Substitute 0 again. I get 2 plus 0, which is 2. So what's the slope of the tangent that we are looking for? 2. Now that we found the slope of the tangent, and the tangent passes through what point? It passes to the point A, which has coordinates 1, 2. This allows us to find the equation of the tangent line. How do we find an equation of a line knowing its slope and a point on it? It's y minus y1 equals the slope x minus x1. So it is y minus 2 equal the slope of the tangent to x minus x1, which is 1. Simplifying, this will give us 2x minus 2. Move the minus 2 to the other side, becomes plus 2. So y equals 2x. Not only were we able to find the slope of the tangent, we are also now able to find the equation of the tangent line. So for the function, the parabola y equal x squared plus 1, at the point 1, 2, how does the tangent line look like? At x equals 0, y equals 0. At x equals 2, y equals 4. it is this line. We are now able to draw it accurately, exactly. Some students might say, why do we need all this? You drew it here. I drew the tangent here. I cannot guess its equation. Of course we cannot guess the equation. How will we guess the equation of a line passing through one point only? We cannot do that. We do not have the tools to guess the equation of a straight line passing through one point. But using this sequence of events, we were able to find what the slope of the tangent is and what the equation of the tangent line is as well. Let me give you another example. Find equation of the tangent line to the function y equal 2 over x at the point x equals 2. See, if we think about it randomly, we cannot reach an answer. If you think about the story I told you, you can always find an answer. What is the story I told you? There is the graph or a function. This is a point on the function. Let's look at what this point is. It's the point where the x coordinate is 2. The y coordinate will be 2 over 2, 1. Okay? I want the tangent. To find the tangent, I need to choose a special point on the curve also, so that this special point is close to this one. How will we define it's close to this one? I will give its x coordinate the value 2 plus h. What we need to be careful about is we do not give the y coordinate the value 1 plus h. No, we take the y coordinate as this function evaluated at this x. Because any point on the curve, so the big note, any point on the curve, any point on the curve looks like x can be anything, but y has to be equal to f of x. So that's why you can choose b such its x coordinate is 2 plus h, but you cannot choose y. What is y? Y is 2 over 2 plus h. So the function evaluated instead of x, you put 2 plus h. These give me 2 points, right? The slope of the secant joining those 2 points is 2 over 2 plus h, y2, minus y1 over x2 minus x1. This is the slope of the secant. I don't want the slope of the secant. I want the slope of the tangent. How is the slope of the tangent related to the slope of the secant? It's the limit of the slope of the secant as h approaches 0. And this is how we fix our formula. So this becomes limit we have worked with so many examples like these. We first substitute 0. You get 2 over 2, 1 minus 1, 0 over 0. Then I have taught you the trick before on how to simplify this without you doing so many fractions. I told you take h as a common factor. Not a common factor. You write this is a over b over c. You write it as 1 over c times a over b times this. So it makes things easier on you because now it's flat. This gives me limit of 1 over h. Take a common denominator. 2 minus 2 plus h. The common mistake here is what? Is forgetting the bracket. So please be very careful. Which gives me limit as h approaches 0, 1 over h. 2 minus 2 minus h. The 2 minus 2 cancels. What do we have left? 1 over h minus h over 2 plus h. You see the h we were looking for up and down? Here we go. They cancel. So what do we have left? And when we substitute h to be 0, what's the final answer? Minus half. And so the slope of the tangent to the function y equal 2 over x at the point 2, 1 is m tan equal to minus half. That's why the equation of the tangent is y minus y1 equal m tan x minus x1. Simplify this, you get minus half x. Minus half times minus 2 plus 1, and we move the minus 1, becomes another plus 1. So the answer is plus 2. Now let's assume for the same problem. Let's assume for the same problem, I want you to find the slope of the tangent at all those x values. We found already at 2, at 4, at 6, at minus 2, and at 10. I want you to find the slope of the tangent. What will you have to do if you want to find the slope of the tangent at all of these? You would have to follow what I just did. How many times? 5 times. Is that convenient? No, of course not, because that takes a long time and we keep repeating the same scenario over and over again. That's why in some situations it's easier to find the slope of the tangent in general. What do I mean find the slope of the tangent in general? I don't want to find it at x with a value. I will find it at x in general. Let's suppose my point A has an x coordinate x. Then what is its y coordinate? F of x. Because remember, A and B are points on the curve. So now B, how will I choose it? B has to approach A, so it will have an x coordinate that is x plus h. Or if x confuses you, call it A. Then this is f of A, this is A plus h. Any number you want, now call it A, just in general. I don't want to put any number in particular. I'm just calling it A. Then A will be f of A. B, I choose it so that it's close to A. Then what is the y value? F of A plus h. What's the slope of the secant? y2 minus y1 over x2 minus x1. This is the slope of the secant. I want the slope of the tangent. What is the slope of the tangent in relation to this slope? It is the limit of this slope as h approaches 0. So this is equal to limit as h approaches 0. What's the function f of a plus h? You take a plus h and substitute it in this function, 2 over a plus h, minus f at a is 2 over a, over a plus h minus a. The a and the a cancel, so what do we have left in the denominator? H. What do we do to find limits? We substitute 0. 2 over a plus 0 is 2 over a, minus 2 over a, h. So what do? We simplify. How did I tell you we simplify such nested fraction? We pull the 1 over h on the side. What do we have left? How do we simplify that? By taking a common denominator, cross multiply. You get 2a minus 2 times a plus h equal 2a minus 2a minus 2h. 2a minus 2a cancels. What do we have left on top? Minus 2h. What do we have left in the bottom? H. We cancel the h with the h. What do we have left? Minus 2 over a into a plus h. When h approaches 0, this becomes minus 2 over a times a plus 0, which is a. The full answer is minus 2 over a squared. So at any point a with coordinate a f of a, what did the slope of the tangent turn out to be? minus 2 over a squared. So this now allows us to choose now all those x values. What's the slope of the tangent? Obviously, according to the formula, minus 2 over a squared. So when x is equal to 2, the slope of the tangent will be minus 2 over 4, which is minus half. When x is equal to 4, it will be minus 2 over 16. When x is equal to 6, it will be minus 2 over 36. When x is equal to minus 2, it will be minus 2 over 4, which is minus half. When x is equal to 10, it will be minus 2 over 10 squared, and minus 2 over 100, and minus 1 over 50. Do you see how simple and fast it is now to calculate the slope of the tangent at so many different points in one shot? Because how did we do it? We did the slope of the tangent in general. We got it as a general formula. We did not do it one step at a time. We did it in a general form. Makes sense? So let's practice another example. Let f of x equals root x and find the slope of the tangent in general. How will we do that? We take a point whose x coordinate is called a. Then the y coordinate is f at a. Choose another point whose x coordinate is very close to this point. And then the y coordinate will be f of a plus h. The slope of the secant is y2 minus y1 over a plus h minus a. It's now concluded that it's h. What is this? When is this equal to the slope of the tangent? When the 2 points approach each other, which means h approaches 0. This is the formula that you can use in order to find the slope of the tangent. If you have a good memory and you don't want to write those 2 points and think that it's a slope of a secant, then the limit as h approaches 0, you can find it using a formula. You can memorize it. The slope of the tangent is the limit as h approaches 0 of f of a plus h minus f of a over h. This is equal to, what is f of a plus h? You go to the function, you substitute a plus h for x. What is f of a? Root a. We substitute first for the limit. You get root a minus root a, 0 over 0. Which means, what do we do? What do we do when we have roots? We multiply by the conjugate. Simplifying, this gives me root a plus h squared is a plus h minus root a squared is a over a minus a. Cancel first. I'm left with h over h, which cancel second. What do we have left? Upstairs we have 1. Downstairs we have this. Because after you cancel a with a first, what do you have left on top? H. So this on top cancels with this on bottom. What do we have left? 1. And now substitute h to be 0 again. What will you get? 1 over root a plus root a. So it is, the slope of the tangent in general is 1 over 2 root a. You can leave it in terms of a, but isn't this a function as well? When a changes, the slope of the tangent changes. So if a is 1, the answer is 1 over 2. If a is 4, the answer is 1 over 2 times root 4. If a is 5, the answer is 1 over 2 root 5. So this again, in general, is a function. So I can call it, instead of using a, I can use what variable? x. It's a dummy variable. If I call it a or x, it's the same thing. That's why one of the formulas is that to find the slope of the tangent in general, it didn't turn out well. Limit as h approaches 0, you can use f of a plus h minus f of a over h, or you can use the variable x instead. And find the slope of the tangent.